Hello students. So this video is on unit number 1 for computer aided engineering subject, which is taught in the Savitribai Phule Pune University. So first we will go through the content of the unit number 1. Title of the unit number 1 is Elemental Properties, and the various topics which are considered in this unit are Introduction to Computer Aided Engineering. Second topic is Use of Computer Aided Engineering in Product Development. Next, Discretization Methods, Finite Element Method, Finite Difference Method, Finite Volume Method. Then the CAE tools, preprocessor, solver and post-processor. Apart from that, element shapes, 1D, 2D and 3D elements are covered in this unit. Nodal unknowns and field variables, coordinate systems, shape functions, linear, quadratic and cubic, convergence requirement of shape functions, derivation of polynomial shape function using coordinate system for bar, beam, triangular and rectangular elements. So this video is particularly this video will be helpful to the students at the time of examinations, when they will revise the when they will take the revision of this unit number 1. So after this we will go through the questions which could be asked during the end semester examination. So the first question that could be part of your end semester examination is write short note on pre-processing, solver and post-processing. So what is basically pre-processing? The computer aided engineering, the analysis in the computer aided engineering subject is divided into 3 stages. That is, first one is pre-processing, second solver and third post-processing. So in pre-processing, it starts with the creation of model of the component or machine whose analysis is to be carried out. Then the second step is importing that model into the analysis software. One can go for any commercial software like ANSYS, Hypermesh, NX, or you can use open source software also for solving the for carrying out the analysis of the simple components. So once you import this model into the analysis software, then you are going to apply the material properties like Young's modulus, Poisson's ratio, density. After that, in the next step, you can select the elements for dividing that geometry into number of small geometry. So this process is called as discretization. Then after that you can apply the loads and constraints. Okay. So up to this, whatever steps we have covered, those comes under the pre-processing. Next, and this pre-processing, you can usually the end user is involved in this pre-processing. You can cross-check each and every step with the help of suitable software. Next is solver. Solver takes care of the mathematical calculations in the analysis. Okay, it is generally a computer program. Okay. It is generally a computer program written for carrying out the mathematical calculation, and it is hidden part of the analysis software. So you will not be able to see any part of the solver. In certain open source software you may came across with the codes of this solver, and if you are having good hands on the programming language, then you can modify the program of the solver also. But in case of commercial softwares, it is a hidden part of the software. The third stage is post processing. in the post processing, mainly the results are displayed. Okay. So the results are displayed in the graphical format. Okay, so different color codes are provided for the stress and displacement values. Usually in most analysis softwares, the blue color indicates the smallest value and the red color indicates the highest value. And interpretation of these results is also involved in the post processing. So both this pre-processing and post-processing, the end user is completely involved in these two stages, but solver is the hidden part of the CAE analysis. So apart from the theory topics, only the numericals on 1D bar, calculation of shape function for the 1D bar and the 2D triangular element, the numericals will be asked only on these two. So next is for the following figure 1, find the value of shape functions n1, n2, n3 for the point P with coordinates 6, 3.7. So a triangular element is shown with the node number 1, 2, 3 having coordinates 2, 1, 8, 3.5 and 4.3, 5.5 respectively. And inside this triangular element there is point P with coordinates 6, 3.7. So basically in the natural coordinates, the shape function n1 is denoted by psi. In natural coordinates, shape function n2 is denoted by eta, and with reference to the property of the shape function, the summation of all the shape functions for the particular element is always 1. So n1 plus n2 plus n3 is equal to 1. So n3 will be equal to 1 minus n1 minus n2. So by using these notations, you can use two formulas for finding out the remaining two shape functions. The x coordinate of point P is equal to n1 x1 plus n2 x2 plus n3 x3, where x1, x2, x3 are the x coordinate of node number 1, 2, 3 respectively. And second formula is y is equal to n1 y1 plus n2 y2 plus n3 y3, where y1, y2, y3 are the y coordinates of node number 1, 2, 3 respectively. So by using these two formulas, you can find out the shape functions n1, n2 and n3. So the third question which can be part of your end semester examination is explain the coordinate systems used in FEA. So basically 3 coordinate systems are used in the finite element analysis. Those are local coordinate system, global coordinate system and natural coordinate system. So while writing the answer to these questions, it is expected that you explain each coordinate system with 2 sentences and a small figure representing the coordinates of the node with reference to certain reference point in global coordinate system. In local coordinate system, the coordinates of the nodes are defined locally, and in natural coordinate systems, the minus psi and plus psi in case of one-dimensional bar element. A simple one-dimensional bar element you can consider for explaining these 3 coordinate systems. The figure will generally carry 1 mark and the explanation in 1 to 2 sentences will carry 1 mark. So total 2 marks for one coordinate system, and the maximum marks for this question can be 6 marks. Thank you very much, students. I will come up with the next questions in the coming video.